Hi all, and welcome back to the Exactpro YouTube channel. We are excited to see you at session 4 of the Python for Machine Learning Bootcamp. Today we'll look into condition and loop operators. This is a type of operator that allows you to execute your code once or multiple times if some conditions are met. Conditions are represented by if statements. They can be simple or compound. Let's recap on the statements we've made previously. The first one had the AND operator, and it goes like this. If I have money for a long trip and I'm on vacation, then I can go on a trip. So for me to leave, both conditions should be met. As we've established before, the if operator works in the following way. If a condition is met, then a chunk of code will be executed. In this case, it's a compound statement. The second statement involves the OR operator. If I'm on the left bank of the river or on the right bank of the river, then I'm on land. This condition is less limiting. It requires either the left part or the right part to be true, as opposed to the AND condition, where both parts have to be true. All these conditions can be used with the if operator. Now, the most complex if statement we've discussed so far is this one. If I'm barbecuing and not running, or I'm running and not barbecuing, then I'm resting. All three of these conditional statements can be applied to condition and loop operators. A loop operator is an operator responsible for iterating the code multiple times. Let's look at an example. Let's say we have a variable titled x. If x is even, then we divide its value by 2 and store the result back in variable x. Here's a flowchart that represents the algorithm. The rectangle says x equals 2. Then we define the condition in the diamond shape. The remainder of division by 2 is equal to 0. If so, the statement is true. We will divide x by 2 with no remainder and store it in variable x. Otherwise, we won't do the division and we'll just display x. X will be displayed in any case, regardless of which path we take. If the condition is met, then we have additional code, and if it's not met, then no additional code will be run. Let's take a look at the code representation. The first line declared the variable. Then we use the if operator followed by the condition, which in turn is followed by a colon. The next lines of code pertaining to the true path are typed using an indent. You can make an indent with the space or the tab buttons. Each line that follows this one should be indented in the same way. Python is quite demanding when it comes to indents. You may think of indents playing the role of curly braces in Python. After the indented block of code is executed, this is when the condition is true, the next line with no indent is executed. So, to recap, if the condition is met, these two lines of code are executed. And if it's not met, then Python will execute this line and this line. As a result of this problem, we'll get an if worked message and number 1. Now let's kick the complexity gear up a notch. If our condition isn't met, then let's multiply the value of x by 3. In this case, we need to use another keyword, else, followed by a colon. This tells us that the code will be executed if the if statement is not true. If it is true, this part is run, and if it's false, this part will be run. Please mind that the else part has indents too. It's important. Indentation has to be the same. Typically, IDEs or code editors prompt you on where and how big an indent you should make, or they do it for you. Either way, you have to remember that indents in Python are crucial. How does this work? Let's see. X is equal to 3. The division remainder will not be equal to 0, and this part of the code will be run. This is where we multiply 3 by 3, get 9, and add 1, and get 10, which we store back into x. We print x and get 10. Now we're making the condition even more complex. We will only work with the numbers that are greater than 1. And we'll set a condition. If x is less than 1, then we'll output a message to the user. And if x is greater than 0, then we'll perform the calculation. So before our existing condition, we've added another condition that's checking the validity of the data. Let's look at the code. We declare the variable, check if x is less than 1, then we output the message. In this case, the result is false. That's why we'll move to the next operator, elif. This is short for else if. Python is prone to saving symbols, hence the shortening. In some respect, it replaces the switch statement that you might have heard of. So here, we're checking if, when we divide x by 2, the remainder will be equal to 0. If it is, the code is executed. If this condition is true, when we divide x by 2, we get 1 and store it in the variable. Here's 1 displayed as a result. Let's substitute 2 for 0 and see the result. So we've received the message about the fact that we can't perform operations with this number because it's less than 1. We also get the value of x, which hasn't changed in this run because none of the code lines modifying our variable with a different value has been executed. Now we're ready to move on to loop operators and look into their work. Let's say I'd like this algorithm to repeat several times. Why not repeat it 100 times? I'd also like to keep track of the variable values that we get during the repetition of the algorithm. The repetitions within the loop are called iterations. So I'm creating a list of my intermediate results. Then I need to create a variable that equals 27, and I'd like to repeat my code 100 times. The condition is the same. We have a correctness check here, and a check for whether the number is even. I'm storing everything into my results list. And after the cycle is repeated 100 times, I'll display the results list. Let's see the flowchart representation. Here's my list, and here's the variable. Here's the count that will track the number of iterations. And here's where I create the condition. If the count of iterations is less than 100, then execute this code. And as we remember, it comprises a correctness check and a parity check. After these operations, I store the result in a list. We should also remember to add 1 to the count. If we skip this step, we will enter an infinite cycle since the count variable won't be changing. After I perform 100 iterations, this condition will return false. And I will follow this option. I'll output the results and end the run. This is how the algorithm logic is implemented in code. We've put in some comments to explain each step. Here's our while loop. While allows us to iterate our code. The loop features our condition of 100 iterations followed by a colon. Please mind that everything that's to be iterated is written with an indent, the same way it was for if. Indents do matter here, while curly braces are not used at all. Here's our list. We append the current value to the list and increase the count. Typically, the count is increased at the end of the loop. There are, however, other syntactic structures that let us write it in the first line of the loop. After the cycle is run, we can display all the values. We actually convert the list into a string, and what we display is the string. We're doing it to make our list easier to read. You can display it without the conversion and see for yourself what's being output. So, having iterated the algorithm 100 times, we've received our list. Let's see what value we can extract from it. I'm going to go ahead and run the code because we'll need the list further on in the session. What we can do here is, let's say, split the list into even and odd values. So I would have to create 2 lists with the values split between them. What's the algorithm here? I think we can do this one without the flowchart, but if you do feel like you need it, just let us know in the comments below. One list will be for even values and the other one for odd ones. Now, we'll use the for operator. It's one of the loop operators that goes through a collection of items. It's okay if you don't know some of the terms here. This just means that it goes through a set of values. In our case, result is a collection of values from a list. The in operator tells us that it will extract value after value from the list and store them in the item variable. So the item variable will accept 82, then 41, and so on. The number of iterations will correspond to the number of values on the list. And at each iteration, the item variable will have a new value from the list in order of appearance there, from left to right. In the loop itself, we'll write a simple script. Do mind that there needs to be an indent. This condition lets us check whether the value is even. If the remainder of division by 2 is equal to 0, then we put the value on the even list. Otherwise, it will go to the odd values list. Here, we've output our results. You can see that the first list has the even values, while the second list has the odd ones. Let's look at a different way of forming a list. For instance, we can do it using the range function. It has 3 arguments: start, stop, and step. These mean the integer to start with, the integer to stop with, and the increments to observe. If we just execute the function, we won't see a list. We have to do a few more things before we get to a data structure. The range function returns an iterator instead of a list, so we'll have to bring it to be in a list. After we do it, we get the list we expected with values from 0 to 99. If you pass just one argument to range, this number is by default understood as the stop value. And the default value for start is 0. So the peculiarity here is that the left bound is inclusive and the right one is exclusive. So the maximum value we'll get is 99 since the default step is 1. We can try and display the output via print. It's a longer line, so it's up to you which way to use. Can we pass 50 and 100? As I said, the left bound is inclusive and the right one is exclusive. That's why the result here would be a set of integers starting from 50 and ending with 99 with a default step of 1. We can pass the step as well. With the same interval between 50 and 100, we will receive a list starting from the minimum value of 50 and the maximum value of 98. Every iteration will add 2 to the current value. We can also perform the operation in reverse if we need to get our sequence in the descending order. Please mind that here too, the left bound is inclusive and the right one exclusive. So to get the same exact sequence backwards, we need to start with 98 and deduct 2 all the way to 49. That way the set will stop with 50. So these are just a few things to keep in mind if you need a reverse sequence. Let's try and execute this code. We have our list. Using the len function, we can get the number of elements in it. We will receive the indexes of every second list item. So the index variable will accept values like 0, 2, 4, etc. Let's execute it and see how it works. There, the 0 index stands for integer 82, the 16 index stands for 364, and so on. So this is essentially how the range function is used by the loop operator called for. It's a frequently used function if one has to search through a specific number of items or do a specific number of iterations. That's when range comes in handy. It's also possible to cut off a slice of an iterable. Slices are a separate feature. They are not a condition or a loop operator. You can easily not use slices for writing algorithms similar to this one. You will inevitably need to write excessive loops and conditions though. In this respect, Python makes your job easier because some of the algos like slices are pre-written for you. Let's generate a sequence of values from 0 to 99. Here's a reminder of the order of arguments for the range function. The same order works for slices. To use slices, we have to put square brackets with 2 colons after the name of the list. There can be 1 colon, but we'll start with 2. These colons separate our input parameters. By default, start is 0, step is 1, and if we just put in 5 between the colons, we'll receive a list of items that starts with 0 and stops with the element whose index is 5. Here's what we get. If we write 5 after the 2 colons, then we're saying that we need the items to span the range from the first value, or if we look at the index from 0, and to the last value with a step of 5. In the meantime, the stop argument very much depends on the length of the list. So using square brackets here makes range context dependent. These brackets know all the elements and their quantity. That's why by default, this number uses the number of elements on the list. So here, we should receive every 5th item on our list. As I said before, we can use 1 colon. In that case, we're skipping the 2nd colon. By default, it will take 1. If we want to get the list of items from the 5th one to the 10th one, then we should write 5 colon 10. Since the right bound is not included, remember to write 11 if what you're looking to get is 10. If you need to get every second item, then use 5 colon 10 colon 2. In this case, you will receive the 5th, 7th, and 9th items. This interval features all the odd values of the list. In addition, indexers like that can accept negative values. Slices for negative values work similar to calling values by indexes. In this picture, you see a scale with 10 items. On the scale below, you see -1, which means that we're using the last item on the list. That's why if we indicate that we want to start with -5, then we'll be taking this element and proceed to the right, so we'll end up including 5 last items on the list. Let's run it. Here are the last 5 items, and here's our full list, and here are its last 5 items. It's a handy function that Python has. By the way, you will not be able to see it in all of the programming languages, so algorithms need to be written by hand there. We can also get the items from the last 10th item to the last 5th one. Start will be -10 and stop will be -5. This is the range we'll receive, -10 to -6, which makes it consist of 5 elements. Since 100 is our right bound, it's not included, then please mind that the value whose index is -5 will not be included. We can also revert the order, let's say from -5 to -10, but make the step -1. Then the values will be displayed in the descending order. Since step 1 is set as -1, we'll basically get the same list in reverse. These numbers don't fully match, but we've already discussed what needs to be done for them to match. So these are the slices you can make for your data. If you know some indexes or dependencies based on them, then you can create slices. For instance, the first or last 5 items or vary step, it's all up to you. Last but not least, your homework. The first task is just asking you to replicate this algorithm. You can let us know in the comments if you can spot the errors hidden in it. The first task has to do with loops, and the second task has to do with loops and if statements. Please replicate it and see if it works. The code here is slightly different. In both cases, replicating the code will improve your programming skills and let you get more accustomed to the syntax. I assume that's one of the things you're looking for if you're watching this course. In task 3, you have to solve a quadratic equation. You need to choose such test data that the discriminant would be greater, equal, or less than 0. Also, let each coefficient be equal to 0 at least once. So, have fun experimenting, and remember to get back to us in the comments if you need help. That's all for today. Good luck with your homework, and I'll see you in session 5.